Cool, sorry to interrupt. I mean, feel free to talk later or now, whatever. So yeah, I'm gonna show you how to learn, how we'll learn Noir in an afternoon. I'll totally give you your money back on this free workshop. And this is, let's say, a beginner workshop, but also something that if you're already working with Noir, maybe it could be still interesting on the latest syntax or the latest way you do things. So yeah, so first of all, like, we're actually going to learn Noir in 1 minute, okay? Not an afternoon. It's going to actually, I'm updating this to actually be faster than 1 minute. So yeah, I mean, if you're like these people, you're like in a, this is Grok made it, great, right? So if you're like in a hackathon or something, you could be someone, oh, yeah, do you know Rust? And there's another one, yeah, definitely, I know Rust. So yeah, then just write Rust. That basically is the purpose of Noir. It's just, if you know Rust, you can just write Rust. And I mean, you just make a small changes that Noir AI will tell you how to do it, and you're good to go. So that's the whole purpose of Noir, it's just to be a language. You just code it as any other language, even if you don't know Rust. And so that's it. Good for you. Let's see you later on. I'm gonna have. Okay, I'm just kidding. Yeah, because maybe you don't know Rust, and that's fine as well. I didn't know Rust when I started working with Noir, and you're like, yeah, it also can't be really the same, right? So let's just talk about like how ZK aren't ZK VMs. No, this was censored. No, this is not about ZK VMs. I'm kidding. This is about learning zero knowledge. And my beef with ZK VMs is that exactly most of them are not actually privacy preserving. So that's what you can do with Noir and you can do with ZK VMs. So we're going to be talking about that. We're going to be talking about Noir and the why is this whole thing. Why do we have a whole big event, the second edition of an event about Noir. And then, yes, then we're going to achieve global peace in an afternoon. So it's something quite easy to do. So let's just start with the zero knowledge stuff. You can bring your own imposter syndrome. I definitely have mine here with me. You can see it. And you're going to see that ZK is actually very simple. If you start with the basics, okay, so here's a little equation, right? I think most of us can understand this, right? So if you're following, like you're like, okay, yeah, so far so good. Now you can just observe something, right? Just observe that this is true, right? That's, I mean, why? Is that a problem? Why is that a problem? Why am I doing this to you? That's pretty much how people like me felt when they first tried to learn ZK. You kind of need to have a PhD to write some code, and that's why we wanted to do something. So you can definitely go these bare bones. Yeah, we did this, actually. Write the constraint system yourself. Why can't you do that? We did it, and we understood that it was not great. So then you have this concept circuits where you can you kind of wire things up like they were some kind of hardware circuits. But yeah, you are like this guy, and you're like, where exactly am I trying to make this XOR gate or something? And this is the state of most zero-knowledge domain-specific languages, you write circuits. And then there comes Noir, and you're like, OK, you write a program, right? And Noir is made to basically encapsulate all the difficult math and all the complexity of the cryptography into a language that you can basically work with. So Noir, like, why do we care? ZK is cool. I don't have to tell you this because you're here, so you supposedly are interested in about Noir. You can prove statements without revealing some of the inputs for that statement or computation. ZK is kind of hard as well. So yeah, people wanted to do something that can be written by normal programmers. And then Kev was like, yeah, I like Rust. Let's just do Rust. They copied Rust. Basically, that's it. Nice guy. And yeah, after 3 years, or I think more than that. It's actually very, very good. And it's very fast. It's probably the fastest language you can write on and do actual privacy with it. So yeah, Noir is the de facto ZK DSL these days. I couldn't say this last year. I would be lying. But now I can, right? You can trust me. It is. Like, no one in there, I mean, even Wei Dai, he was saying no one in their perfect mind would actually think about using another ZK language to write whatever, right? This is Wei Dai, so kind of the big boss. Anyway, what do you want? You want something that's fast, that doesn't take a ton of time to learn, and doesn't take a ton of time to prove. Like, your users won't be staring at the phone for 10 seconds, like, right? 10 seconds without Twitter, that's not going to happen. You want something that is also powerful, that you can do things you can't do without this very complex math. And then you want to be something that is actually useful, that works on a phone, for example. Yeah, that's our main goal. So some examples, and then I'm going to go to the actual beginner stuff, where we're going to be live coding. You can follow along as well. I prepared something for that. So a simple guessing game. This is a very simple example. We're going to have this one because it's the standard like first example you're going to have. Yeah, try to guess my number. Good luck. That's the basic circuit. So you can have you can think of a field as a kind of a big integer, and you're basically saying all the inputs are private except for the ones I'm saying that are public. And then you just make your computation and say, prove that x is different from y. And that's what the verifier will check. That's the main smallest example you have. For something that is more interesting, and actually nobody has done this yet on Web 2, and I don't know why, is knowing that you know the hash of a password. We may actually do this for the workshop today, where you prove you don't give your password to the website like usually people do. Just give your password in plain text and trusting HTTPS, and then trusting the backend to not log your stuff or not store your password in plain text. This is not how you should do that in 2025. You should actually send the hash of your password and then send a zero-knowledge proof, proving that you know what is the preimage of that. So it's one line of a circuit, right? It's a circuit that has one line. You just import a hash, and then you import the actual plain text password, and then you prove that whatever the verifier knows, that will be the public hash that everyone knows, that's fine, it's a hash, is equal to the hash of the password that you know, without revealing what is the plain text password. So this is very secure. Like your password actually never leaves your device. You generate the proof there. And why didn't Web2 developers pick that up? I don't know. Maybe they don't know about ZK. Because it's pretty impressive. And then semaphore, I guess classic example of semaphore. There's actually open RNG for building actual V4 version of semaphore in Noir. And so, yeah, proving you are part of some kind of real human group. And this has been done for WorldCoin working on that. ZK Passport, pretty much every protocol uses this kind of semaphore construct. And actually today at 1:30, I'm going to be here for out of schedule, I would say. I mean, it's scheduled, but not in the paper. Where I'm going to walk you through a simple Merkle tree and how to use a simple Merkle tree, because it's pretty much, I mean, there's a big range of solutions that will eventually depend on you proving what is a Merkle tree. So, but this is, sorry, yeah.
Are you taking questions?
Yeah, sure.
Are you going to at some point show sort of how Noir does witness generation versus constraint checking?
I will, yeah.
Yeah. Very curious about
that. Yeah. It is fast, like, that's what people ask me. Oh, but it's not fast. I don't care. I'm going to tell you why I don't care. It's actually faster in most situations. I don't think there's any situation where there's any other language that it's faster than Noir, but it doesn't care. We don't care. And actually, it even depends because, like, you do have different backends, so it then depends on what kind of backend you choose. So if you choose broad 16 backends, then you're going to be faster than if you use Plonkish backends. Like the default, the one we're going to be using today is a Plonkish, and you're going to check that it's actually faster than broad 16 in most situations. It also depends on your program. Like, it's up to you to optimize it as best as you can, right? We want to make you write a program and it will be optimized as much as possible, but it's definitely up to you. If you're Zach, you're going to be able to do something that's incredibly faster because you're going to understand what are the complexities about the underlying system. And then this is what I want. It's the app, because if you've worked with Groth16 backends, you know that you need to download a huge proving key. It could be 30, 100 megs that works for one circuit. Can you imagine? If you're like working with ZK Passport, you have one program that's supposed to work with many different, you have different programs, one for each different passport. There are many different versions of your passport. So if you have an app, your user is going to go to the app, going to choose what password there is, and then the app will download a 300 megabyte key. That doesn't work, right? What you want is something that you download a 40 meg app, and it runs every circuit that you want, whatever passport you have, right? That's the actual product that you want to ship, not something that is faster, but whatever doesn't work. So yeah, I don't care about benchmarks. Nobody cares about benchmarks once you're actually starting to build a product. And yeah, so I can say this with all confidence. Noir is the only usable ZK DSL. I mean, you can write code, not circuits. I mean, yeah, again, this I was just mentioning about like the fact that you have to have different zero knowledge, different proving keys for different circuits, which is not great. Yeah, I mean, there's the whole thing about the gas cost. Yeah, definitely a Noir Plonkish solidity verifier can be a little bit more expensive, but honestly, like, it's not that you're going to pay for a Groth16 L1 verification anyway. So you're going to always choose an L2 to verify your proofs anyway. And then, yeah, it's just the mobile friendliness of Noir, which is a big deal. You can actually do things on the phone with the progressive web app, or with a native app, even better, even easier, even faster. But it works on a phone. So eyes on the prize, 60% of the traffic, and maybe more of the consumer traffic online is on mobiles. If you make an app that's all great but doesn't work on a phone, you're not going to make it, okay? So yeah, about the global pace in an afternoon, yeah, I may have oversold that, so let's just go through the agenda of the workshop. Let's see some Noir tooling, then we're going to write some Noir code, and then we're going to prove something, okay? That's basically it. Cool, so there are some links here. You can maybe zoom if you want to scan. This is the Aztec Discord. I know it's Aztec Discord, should be Noir Discord. Anyway, ping me, and I'll give you the Noir Discord link. This is noirlang.org. This is the documentation. Just remember, I mean, yeah, 5 hours debugging will actually make you spare 5 minutes reading documentation. So yeah, choose wisely. And here is my link tree. Has all my socials, but also has workshop resources, which is not big, but it's cool because well, I'm gonna show you why. But there's a code space that I pre-built, so we can skip on the installation of Noir and everything. Yes?
What's the best resource for Groth16 backend?
There is no documentation around like building other backends, but there is a team working on Plonkish, but Plonkish is Stark. I'm gonna have to go back to get back to you with like which one is working at the time. Yeah. Yeah, but I honestly, like as a developer, I don't see a situation where we would choose a Groth16 at the backend at this point. Yeah. Cool. I don't see phones in the air, so let's get started here. So this link I showed you is for this. when you can create a new code. Actually, I'm going to mirror my screen because it's so I don't have to look like this. This place. Mirror. How do I mirror? Mirror, mirror, mirror. Mirror. Cool. Yeah, much better. Okay. Cool. Okay. I guess this should work. Yeah. So you'll end up on this screen. You can choose whatever here. Actually, gotta tell me if this says that I'm gonna pay by me. It's fine. I just wanted to know because I never tried to log in with a different account, so I'm curious. But yeah, you can choose whatever machine type. I'm gonna choose it fairly, so we don't have to like wait for a long time. But here, it will basically run VS Code, full development. Environment that already comes with Nargo and BB, and this is useful for today because we don't want to spend much time with installing these. If you want to do that on your machine, you can go to noirlang.org, and the quick start tells you how to install Nargo and BB. Yeah, sure. Can I? I don't know. How do I do this? Maybe Linktree? Or no, Linktree won't work. Just check here. Come on. Oh, here. Yeah. Okay. Yeah, here. So it's you'll check in the Linktree, and then within there's a link. But you can actually go to, I think, code spaces, new. There is, yeah, you got code spaces /new/senioricello/tinynoir code space, and it will work. Also, I think there's like new code space something that there's another one that you can use. Yeah. Cool. Can we move on? Okay, take that as yes. So yeah, just choose whatever machine type. It should be pre-built, so it will hopefully be fast as well in getting started. In the meantime, I'm gonna pull up the Noir documentation because I often forget about stuff. But again, you can go to the getting started, and what I'll be doing today is pretty much what is in the getting started. But what the code space does for you is all this installation of Noir and the proving backend. So we can basically skip that. So yeah, as you can see here, and I should have Nargo here, and I should have BB as well. Cool. Can you see it? Should I zoom in maybe? Yeah, I guess so. Oh, come on. I told him to not sync my extensions. Please don't sync.
So once you create a new code space, how do you get the OR code space up?
It immediately should start one. Like so, when you go to code spaces new, where is that? Here. You should get to this screen, and you just click create code space, and you will basically start this. Here, you click just create code space.
Oh, I mean the
yeah.
URL up there.
Here. Oh, the URL, yeah.
Yeah.
I should maybe like create a subdomain or something. Tell me if I'm going too fast. It could happen. Reload. Come on. Why is it trying to install all my? Oh, not. Because I don't care about my extensions. By the way, there's an extension that should be already installed by default. That is Noir. Okay, it's somewhere here. Somewhere here. There's gonna be Noirlang. So, yeah, this basically it's a really cool tool that will give you not only the syntax highlighting, but will always also give you autocomplete. It will give you nice, runners for your tests, so you can run one or the other. It will give you a language server. It will check linting. It will format the code for you. It's really, really a powerful tool. So assuming that this worked out for you, we can basically start. And to start, I'm going to go with Nargo new, and Nargo new would be Nargo new NoirCon 1. Okay, and this started a new program. So let's just have a look at this. You know, Nargo.toml, it's pretty much like Cargo.toml. Like you're going to see a ton of the names are inspired by Rust because we really like Rust. So Nargo.toml will basically, it's the name of your package, authors, and also the dependencies. So if you want to import a dependency, you're going to be doing that. And I'm going to be doing that later on in the next workshop. There's also, if you want to build a library, for example, we'll change that. And then we have the main.noir, which is the actual program that you are going to run. So it already comes with one by default. So you can already go and write Nargo test, it will work. Okay, no. It's NoirCon 1. And this will already work, okay? So this is, you can start with this boilerplate. But yeah, I don't care, so I'm gonna comment it out. And so I just have this, just think about this idea of you are a member, you are Brad Pitt, okay? Maybe not as good looking as Brad Pitt, but you are Brad Pitt. So you're part of, it's spoiler, right? Maybe it's not spoiler, yeah. You're a member of a fight club. But one thing about the fight club is that you want to have a password to enter, right? And it's just like the website. You don't want to give the password to the bouncer at the entrance of the fight club because you don't know what the bouncer will do with the password. Maybe it's an interested person. Maybe it will hack you. Maybe it will, I don't know, put it in a notepaper and then sell notepaper. You don't know, right? So what you want to do is you want to prove that you know the password without actually revealing the password. So how do you do this? How do you do that on a phone, right? Like, so let's start with that. Like, first of all, you need a hash. So actually, let's just start with the plain password, okay? Plain text password, okay? And you're like, oh, you're already giving the password? No problem. This is the private input. Like, none of this will be accessible for the verifier. The verifier will only see what is written in with pub, right? So this is where you're going to say the password hash. So that's it. Basically, your circuit, your program will prove that you know this one, and that hashing that password will actually be equal to the password that your verifier knows what it is. So when you go to the bouncer, if you're the manager of the fight club, you say, oh, the password hash now is this one. And that's fine. Everyone can know that. It's not like people can track you by knowing something that is public. What you want people to prove is that they know what is the pre-image of that. So for that, you need to import a hash. Basically, in your program, you want to redo the hashing. And by redoing the hashing, you are proving that you know that it matches the one that everyone knows. So you can use STD, which is a standard library. If you want to know more about the standard library, it's really great. And you can go here on the Noir language. And you have all the concepts. And here's standard library. And here you have everything you can do with the standard library. Spoiler alert is amazing. You can do the craziest things with the standard library, right? So yeah, this is just one of the hashes, which should be, I guess, in one of the cryptographic primitives, and we're going to just use one of them. Okay? So this one, it's a hash known as Poseidon hash, which is probably the most useful hash you can do with ZK. So STD, I'm going to hash, I think it's like Poseidon 2, and then Poseidon 2. I can check in the documentation if I mess it up. Hash. I think this is the one. So you are importing this dependency. And now your circuit is just as simple as hash, plain text password. You also need, oh, this is a slice, so you need to make it an array. And then you're just hashing one input, so just pass one. And again, that's it. You just prove that that is equal to the password hash that everyone knows. And yeah, I see my, how can I say, the server, language server is not working here, but that's fine. I can always go and say nargo check, and it will tell me, I mean, if there's any problems, nargo check will give me like an error or something. Yes?
So this private plain text password field, how is the prover doing this without knowing that?
I will do it. I'll show you
Okay.
just now, yeah. The prover will know. The prover is your user, like he knows, that's the point, but the verifier won't.
Okay.
The verifier is the smart contract, is the bouncer of your Fight Club.
Okay.
So it's really cool, right? You're going to see that the proof actually doesn't contain any information about what is the plain text password. It only contains information about what is the password hash.
And so this code is actually executed on the client?
Yeah,
Okay. And
on the phone or laptop, whatever. Yeah, pretty cool. Yeah. If you want to run some tests, Nargo already has some cool things where you're going to have like, I don't know, hash of 0x1234 will match something. I don't know what's the hash of 01, 1234, what's the Pasana hash. I mean, I could always like print it out here and see what it is and then use it as a test, for example. But you can also have like, tests that are supposed to fail, which maybe this is the good thing to try now. And say, a test that should fail. So I know that if the test fails, then I'm good. It's supposed to fail. So it test that passes if it fails, right? So, okay, it passed when it should have failed, okay. This is just, I would say just wrong.
Your cert, you should have had equals?
Yeah, sure, of course. That's why it passed. Yeah. So yeah, it passed because it should have failed and it failed. So this is very simple. Again, you can go to the documentation. Yes?
So my IDE wants a second parameter to the hash function. Oh,
Yes, I'm passing one. It's the number of inputs you can have. Because you can have different inputs for whatever reason, it asks you for the number of inputs you have. So, and for your question about the prover, you actually have this file that is created when you run nargo check. And it will create this prover.toml file. And this is what you're going to be doing on your client. Usually, if you're building like a web app for a phone, for example, for a phone app, you're not actually going to run Nargo at all. Like, you're going to use Noir.js, which is something I will show in the next workshop at half past one. And this is basically the JavaScript version of Noir, which is usually you're going to be doing some kind of Noir React Native, or going to use some kind of React, or I mean whatever framework you use on your front end, and so you need a JS version for Noir. So yeah, here like you're gonna go and zero like 1, 2, 3, 4, and then the plain text and then the plain text password here. So just to show how this works, I'm gonna actually go and say try to output what should be the result of this. So and say print line, right? Print line. I'm gonna do hash of plain text password, just to know what is supposed to be the output. So, and then I'm gonna nargo test with show output, and it will, of course, 1, 2, 3, 4. So yeah, this should be the hash we're looking for. So yeah, just going back to the test, I can actually now run this as a test that should pass. So I can go here and say this test should pass, and hopefully, if everything goes right, it should pass, right? Because the hash, Poseidon hash of 1, 2, 3, 4 is indeed this. So yeah, just for you. I kind of deleted everything. So you can go print line, and then hash of 0x1234 1, and this should print when you run it with nargo test / show output. It will print what is the hash of that, right? You could use like Poseidon.js, or you could use, I don't know if there's any online service that will give you the Poseidon hash of something. Maybe that should be a nice, I would say, like hackathon project or something. I see confused face here. Is
error number too large to fit in target type?
When you run nargo check? Did you quote it?
I did nargo execute.
Oh yeah, that's nargo execute.
I put it in the prover.toml file.
Yeah, let's go there and see what happens. So yeah, I'm actually gonna copy this one, this hash, gonna put it in the prover, password hash, and I think this is it. Yeah, so nargo execute, right? You're saying? Oh, I think you need to quote it when you run, when you put it in, because it's TOML file, so it needs to be, yeah. You need to quote the number. That's just TOML syntax. You can just put this. It will try to read it as a number. So cool. I mean, if I change something here, so just put in E, it will just not work, right? It will say, I mean, it will fail constraint. It will immediately not even try to do something. So going back to my F, which is the correct one, cool. And you're like, cool, now I have the witness. So what is the witness? The witness is basically a solution for your circuit. This is something that you as a prover, only you know, but it is like a solution for the polynomial problem that is built by Noir. So when you run a proof, you always need to generate the witness, and then you need to prove. You do that all in one go, all in client side, right? So when you run nargo execute, that's the witness generation. And it's very difficult to understand what is here. Like it's meant to not be human readable. Now you're good to prove. And that's it about Noir, actually, because now you're going to the backend, right? So Noir is only the front-end language. Now you need a prover. And that's where you can actually have different provers. You can take this, you can think of like the ABI of the circuit. You have the witness, and you could put it in whatever backend that supports Noir. It will read it, and it will prove for you, right? So in our case, we're going to be using Rattenberg, which is the backend that Aztec Labs developed, and which is already installed in our code space. You can run BB, okay? The documentation is not great. Okay, it's horrible, but this is ongoing work where we're going to actually have a help command and everything, because I don't think it even has a help command. Yeah, it's just horrible. But this is one of our team members is actually working on this week, but it's not here. So, but there's a documentation on the Aztec packages repo. You have on the Rattenberg page. There's some not even documentation, but some hints of how to do stuff. But that's cool because we only need to prove things with it. It's not a big deal. So you can actually go and run Noir proof, BB proof, right? And if I gave it a different name, so I actually need to pass all the inputs here. So it was not great of me. So you can pass B, which I think is I can go targets NoirCon JSON. Again, if you just do nargo init without anything, it will start an example project, and then I'll just use that. So I'm going to pass the program. I'm going to pass the witness, target NoirCon1.gz, and then I'm going to also say where I want my proof. Say target proof. And that's it. Like, it errors, again, just tooling stuff. And here's your proof. You're maybe like, how do I see this, right? I mean, you can cat it, I think, cat proof. Right? Oh, target. You can see the proof here. Okay, not with the correct thing. But there's, I think in the documentation, actually, if you go on the quick start, there is a little snippet you can copy, to basically show you the proof, how it looks like. So you can go here on the quick start, just copy the last one, and yeah, this is this is actually just the public input. So one thing about this is like just cut this, so I can show you the whole thing. So this is the proof. So it's a ZK snark, so it's a fairly small proof. This is small, right? You guys know this. It's a small proof. Snark, succinct, non-interactive arguments of knowledge, right? Arguments of knowledge. So, and one thing you're going to notice is that the beginning of it is actually your public input, okay? And this is just how Brothenberg works, okay? But that's fine, it's public, right? You can just do it. And I don't know exactly why does Brothenberg append the public input to the proof, but actually when you use it on a smart contract, the smart contract will likely want it separated. So you want to split. The Noir.js will do it for you actually. Just split the public inputs from the proof. But this is the whole thing. Like you have it, right? Now you want to verify this. You're like, oh, okay, good. Now imagine I am the verifier. What happens if I want to verify this, right? So in another machine, you just have the circuit, you have the proof, and you know nothing besides this hash. How do I verify it? Right? That's the question you want to ask yourself. So I can actually start a new code space with that, but I'm not going to. Just trust me. So you need to generate a verification key. The verification key is a very important piece of the circuit because if a circuit changes, it has a different verification key. So you want your verifier to be sure that he's verifying the proof for that circuit, not a different one, right? Otherwise, they could just do whatever. So the verifier will actually have to take the circuit, compile it as we did it, the Noir execute, Nargo compile. That will give you this ABI, right? This ABI has all the bytecode for the program, also has the plain code apparently for the circuit, which is fine. Like that doesn't reveal any information. And with this, you're going to generate what would be the verification key for this circuit. So I don't exactly recall what is the right VK. I think it's right VK. And then it's going to point. Let's imagine that I'm on another machine. I'm going to point to my circuit. I just compiled it. I'm going to go target NoirCon 1.json, and this should be it. Cool. So again, I didn't need the input to generate the verification key. It's there. You can use it, right? And so in this other machine, you have the verification key, and then you're going to receive the proof by the guy at the bouncer at the Fight Club are going to get the proof. But you have generated the verification key on your side. We'll be sure that the proof that you get is actually for the circuit that you want them to prove for. So now you can verify. You can go BB verify, and the verify is just going to pass. I think you still need to pass this, the VK. The VK, or I think it's key. I don't even know exactly. Target VK, and the proof, right? This is all information you have about. It's just verification key that you generated, the circuit that you generated, and the proof that's the only thing that reveals nothing about the private input. So you're going to go past the proof, which should be P. I don't know. I'm going to check the docs. I don't know. Documentation will tell me. Verify K. Oh, okay, cool. Oh, cool. Yeah. Obviously, you don't even need the circuit. You just need verification key. So you can actually go here and say BB verify. You just pass the key and say target VK and then the proof, target proof. and that's it. Like, it's kind of silent, but it works. If you change the circuit, if you change the proof, it will fail. I can easily change the proof here, but that's it. You say I don't need to input the public inputs. That's fine. They're public, right? So you can. And now another thing you may want to, and I don't know if I think we're going to have another workshop. So, but I don't see anyone. So, I guess we can just keep going. Which is you're like, cool. This is great. Works on my machine. Hopefully, you want to do this on a smart contract. And big advantage of doing that on a smart contract is that you don't actually need to have someone else in specific to verify your circuit. And this is useful because in the case of the Fight Club, you have one bouncer. I mean, there's only one person at the door. But if you want some kind of, if your Fight Club you have a lot of them, like it's a franchise thing or whatever, you may not want to trust the bouncer, right? So you're like, what if I could have some program in the cloud that will always verify my proofs? And I can be perfectly sure that it will always verify, it will never cheat. Will never say that, yeah, this person knows the password, right? So that's the big advantage of doing that in a smart contract. And cool thing about BB is like it generates a smart contract for you, but you can go BB contract. And I don't think it needs anything else. Yeah, just BB contract. Like it already gets the VK from here and generates a contract. The contract looks terrible, but that's fine. You don't need to understand it. But this is basically what the verifier is doing, right? This is the math that we hide from you in Solidity form. So now you can actually deploy this contract. So I can go, I don't know if you know Remix. I suppose some of you know. Remix is a nice IDE on the web that you can use to quickly generate smart contracts, compile them and everything. So I can go to remixproject.org. I'm going to run the IDE. I'm going to start a new program, new thing. No, it was way too, okay, create blank. I'm going to create a blank project. I'm going to create a contract here. It's going to be c.sol. It's going to be the same one. Just going to go to this code space, to this contract that it generated. I'm going to copy it, paste it on the IDE. It will complain because it say, oh, you shouldn't trust this. Yeah, I trust. Okay. And now you can compile it. So actually, I'm just checking what's the version for that. That's 8.4. Yeah, that's weird. But yeah, you can basically use any compiler. Oh yeah, you need to optimize it. If you know the stack to deep thing, it's very annoying. You need to optimize it. This is ultra plonk. So this is the old version of Noir. It's the one that's cheaper to verify on chain. It's also, I think it's still not the default, but it should be the default. The default now, or the default should be the honk verifier, which is the fastest prover that we have. So, but yeah, I'm showing you the old one, that's fine. So it did compile, and now I'm good to actually deploy this. I'm going to use just the Remix VM. I'm just going to choose the Ultra verifier, I'll deploy. I do have a contract here. You can actually get the verification key. See, this is the cool thing. You can actually see the verification key. So you know that you're going to verify the circuit you are supposed to be verifying. And now I'm going to go to my code, and I'm going to split it, right, with this thing I used, just to get just the public input. I don't need to. I have the public input here, right? Where is it? Yeah, here. I'm just going to put my public input in my proof. It will say my public input. So I'm gonna, yeah, I think this should work. And then my proof, what I want, the proof, I actually want the tail, not the head. So I want the tail. Or, I don't know if I know too much about the tail, but it's good. I can just, I guess, copy the rest of it, something like that. Let's go to copy. Oh no, oh, it's here. Yeah, where is it? Oh, because it has a 0x. Just gonna Cool. So this is the rest of the proof. Just gonna copy the whole thing. And here, you can copy it. You can go back to the Remix IDE. Just gonna put the 0x at the beginning. And hopefully this should, it's odd length. Okay, now maybe you need a 0 before because odd length. Array value. Which one is the odd length? Maybe this one is the odd length. I mean, it has to fail, right? It's anyway. Yeah, it should work usually. Let's just check, verify. Public inputs. So I'm definitely doing it correctly, I think.
We might have to be kicking you out soon.
Yeah, that's good.
Is that cool?
Yeah,
Okay.
we're finished actually.
Yeah, we'll give you-
Yeah.
Yeah.
So it's cool. I mean, we're gonna be here again at 1:30 with a more advanced example. Even if you're beginners, you're feel free to come. It's gonna be cool. I'm gonna show something working on a phone. Yeah. Thank you. I don't know if I have any questions, since we're not being kicked out yet. So.
I had a few. So when you generate the witness and the prover, are those sensitive? Can I use those to like do a reentrancy for whatever you did the first time?
You can, yeah.
So when you generate them locally and then you make the proof, it's the best practice to just delete those off of the client? Or is there a safe way to, do you need to keep those around for anything?
You don't have to keep them around, but they are. You can do some kind of reentrancy attack, where especially with smart contracts, or say, oh, here's my proof. I mean, your node can actually steal the transaction from you and front run you. Okay. So you need to be careful with that. There's actually at the half-hour workshop, I'm going to show you how can you avoid that. Okay. But usually if your prover is on a phone or something, or it's proving, you can keep the proof around. It's just date. It just stays on the phone.
And then the witness, is the witness more sensitive than the prover?
No.
Or neither of them?
Neither of them you should be putting them on chain or anything, but there will always be on. It's sensitive, yeah.
But about the same.
They are as sensitive. Yeah, I mean the proof you don't wanna reveal the proof. The proof you wanna reveal, but it can be reused.
Because the proof is what I actually submit to the sequencer or the node.
Sequencer, no, yeah, in a transaction in the case of Solidity or locally.
And the Bratenberg BBE thing is how you take the prover and the witness and make the actual proof.
Yes.
And that also happens on the client.
Yes.
And then you were saying a smart contract does that. Because there's an account contract is something I keep hearing about, and that's something that would actually generate its own proof.
No. I mean, it generally don't want the smart contract to generate a proof. Some people have done that with I think there's a talk later on with the guy from Noir. He's gonna probably be talking about that. I don't know, but I would say that it's probably where he's going to. We're having a proof being done on a distributed machine like Noir, and this is doable. But there's little scenarios when you want to actually give private inputs and get a proof back, right? Usually want the smart contract to verify your proof. You want the proof to be private. You don't want to reveal the information. So if you ask the smart contract to generate the proof, then you're telling them the private inputs, right? So that's kind of fits the purpose. But it's doable, yeah. Cool. There's someone for the workshop. So cool. See you later. I'm going to hang around as well. So thank you.